second law can be summed up in the equation net force equals mass times acceleration. Net force is the sum of all the forces acting on the object. To help you find the net force on an object, it always helps to draw a free body diagram. These are pictures that label all forces acting on an object, and the object is usually drawn as a box. Mass measures the amount of stuff an object has, is always measured in kilograms. Remember, mass is not weight. Weight is mass times gravity and is measured in newtons. To get from kilograms to pounds, you multiply by 2 by 2. To get from pounds to kilograms, you divide pounds by 2.2. Acceleration, which is change in velocity, always points the same direction as the net force. There are many special forces. One is friction, and it acts opposite to the motion of the object. Friction is caused by imperfections on the surfaces. The equation for friction is lowercase f equals mu times the normal force. Fn is the support force. Mu is the coefficient of friction, and it measures the stickiness between two surfaces. It's always less than 1 and has no unit because it's friction, which is a force measured in newtons, over normal force, which is also measured in newtons. To find net force with friction, just add the force applied with friction. Force applied, which is F lowercase a, is the force being applied to the object. It can also be the force of tension. There is also friction in the air, which is called air resistance. The symbol is F with a capital R. In the absence of free fall, all objects fall at the same rate, which is at gravity. Gravity is 10 meters per second squared, which is also acceleration. It's also a special force with the equation Fg equals mass times gravity. At every second of free fall, objects gain 10 meters per second of speed, which can also be found with velocity equals gravity times time. To find the distance fallen from rest, use the equation distance equals 1/2 gravity times time squared. During free fall, the object can reach a terminal velocity. That means the object has reached a maximum speed because the weight of the object equals the air resistance. At this point, the object is in equilibrium. What is equilibrium, you ask? Well, it is when net force equals 0, because acceleration equals 0. But how can net force equal 0 when an object is moving? Well, there are two types of equilibrium. Static is when an object isn't moving, so it's at rest, and dynamic is when the object is moving at a constant velocity in a straight line. Remember how acceleration equals change in velocity over time? If velocity is constant, then the change in velocity equals 0. Acceleration equals 0 over time, causing acceleration to equal 0. Two key points in remembering equilibrium. The push force equals the resisting force. And also, two forces must be acting on the object to make it go at a constant speed. To further explain force of gravity and normal force, let's look at this elevator. Key concepts to understand is that force of gravity is always the same. The normal force can change. This is because gravity never turns off. It'll always be a downward force going at the same rate of 10 meters per second squared. Normal force is the support force, pushing up against the weight. This force allows the object to move up or down. So, starting at rest, rest always means that your normal force equals your force of gravity. This also means that your acceleration is 0. This is also true for constant speed. Remember, constant speed means 0 acceleration. So going up, speeding up, means that the floor pushes up greater than the weight of the person pushing down. Therefore, the person can accelerate up. Now, Going up, slowing down means that the support force is less than the person's weight because the person wants to keep going up. But since the elevator and the person move together, the force pushing up reduces. Going down, speeding up, means that the floor pushes up less than the person pushing down because the person wants to stay at rest. But since the objects move together, the upward force reduces. Going down, slowing down, means that the normal force pushes up greater to accelerate the person going up because the person wants to keep going down. Note that the acceleration for speeding up going up is positive. The acceleration for slowing down going up is negative. The acceleration for speeding up going down is negative. And the acceleration slowing down, going down is positive.